Okay, let's answer our next problem we have here. A sand cone test has been performed on a soil sample in a compacted field. The test results were as follows. We have the initial mass of sand cone apparatus with sand, the final mass of sand cone apparatus with sand, the mass of soil recovered from the hole, the moisture content of soil from the hole, the density of sand, which is the Ottawa sand, which is usually used in the sand cone method test in performing the field dry density test of compacted soil. And then we have also the volume of cone below the valve, and then the maximum dry unit weight of the compacted soil determined in the laboratory. And we are required to get the value of these requirements. We have the moist unit weight of soil, the dry unit weight of the compacted soil, and the relative compaction. So first one, we just have to draw our setup of our sand cone method test. So let's assume this is our sand cone device. And then initially, our sand cone device is filled with Ottawa sand. And if this is our compacted field, from our compacted field, magbobore lang tayo mismo ng hole, hukay tayo dyan, and yung mahuhukay natin mismong lupa dito, dadalhin mismo kay laboratory para matest mismo yung kanyang maximum and minimum values ng kanyang void ratio and dry density and dry unit weight. After na maalis mismo yung lupa dito, ilalagay natin mismo invertedly yung ating sand cone device sa ating hole. And then we will open the valve here para mag-flow freely yung ating Ottawa sand papunta sa cone and then sa ating hole. So this will be our setup hanggang sa ma-fill mismo yung ating hole at saka cone. And then pagkatapos nun, i-close natin yung valve and then aalisin natin mismo yung ating sand cone device sa ating field. So ito yung kanyang final setup. And from our problem, the initial mass of sand cone device with sand is 5.912 kilograms. The final mass of our sand cone device with sand is 2.378 kilograms. And then our first requirement is to compute for the moist unit weight of the compacted soil. And we know from our first topic that the moist unit weight is the ratio of the total weight of the soil with respect sa kanyang total volume. And sa ating problem, wala pa pong binibigay na total weight and then total volume para sa ating compacted soil. So, kukunin muna natin yun para makuha natin yung unknown requirement. First one, get the value of the total weight of the soil. Yung total weight of the soil, pwede natin siyang i-relate mismo sa binigay na parameter sa problem natin, which is the mass of soil recovered from the hole. And that is weight is equivalent to the product of the mass of the soil and then the gravitational acceleration. So, substituting, the mass of soil recovered from the hole is 2.883 kilograms. Then gravitational acceleration, that is constant, 9.81 meter per second square. And that is kilogram meter per second square, that is already in newtons. Make it in kilonewtons. Convert natin, multiply it by 1 kilonewton is to 1,000 newton. Therefore, the total weight will be 0.028282 kilonewtons. So we have already the value of the total weight. Now, get the value of the total volume. The total volume of the excavated soil is also the volume of the sand in the hole, and that is also equivalent to the volume of the hole. So, total volume is the volume of soil, that is also equivalent to the volume of sand in the hole, and then that is also the volume of the hole. Pare-parehas lang po mismo yun. So to get that, first one, let's deduct first these two values. Kapag dineduct natin mismo yung ating final mass ng sand cone device, na may remaining sand sa ating initial mass ng sand cone device na may sand, makukuha natin mismo yung mass ng sand na pumunta kay hole at saka kay cone. So we have here the mass of sand in the cone and then the hole, that is equivalent to the difference of 5.912 kilograms and 2.378 kilograms. So computing, the mass of sand in the cone and in the hole is 3.534 kilograms. And then we will use the density of the sand. And we know that the density formula is the ratio of the mass with respect to the total volume. Since we have here a value of the mass of the sand, and we have the density of the sand, we can get the volume of the sand. By cross multiplication, we can get the formula of volume, that is mass over density. So, since yung mass ng sand na gagamitin natin dito is mass ng sand in the cone and hole, ang makukuha natin is the volume of the sand in the cone and the hole also. So, volume of sand in the cone and then the hole is equivalent to the mass of sand in the cone and hole, 3.534 kilograms, divided by the density of the sand already given in the problem, 1,300 kilograms per cubic meter. Kakancel mismo to. Yung maging unit natin is in terms of cubic meter. And that will be equivalent to 0.00272 cubic meter. But then, ang kailangan natin mismo para makuha yung ating moist unit weight is yung V, which is the volume of sand in the hole. Meron na tayong volume ng sand sa cone and hole. Para makuha mismo itong parameter na to, that is volume of sand in the hole only is the volume of sand in the cone and hole. Ima-minus lang natin mismo yung volume ng sand na nakay cone. So, makakancel yung cone, hole na lang mismo ang natira. And that is also the total volume of the excavated soil. And that will be equivalent to the volume of sand in the cone and hole, already computed, 0.00272 cubic meters, minus the volume of sand in the cone, which is also the volume of the cone. And that is already given in the problem, 1.114 times 10 raised to negative 3 cubic meter. So, computing the value of the volume of the sand in the hole is 0.0016 cubic meter. So, we have now the value of the total weight and the total volume of the excavated soil. Therefore, computing for the moist unit weight, that will be equivalent to direct sub 0.028282 kilonewtons over 0.0016 cubic meter. And we will get a moist unit weight of 17.627 kilonewtons per cubic meter. And that will be our first requirement. Our second requirement is to compute the dry unit weight of the soil. Again, to compute that, formula of dry unit weight from our first topic, soil properties. The dry unit weight of the soil is the ratio of the weight of soil particles with respect to the total volume of the excavated soil. we already have the volume of the excavated soil. Problem na lang natin is yung weight of dry soil. But we can relate the weight of dry soil sa ating total weight since meron tayong moisture content ng ating soil excavated from the hole, which is given in the problem 7%. And that is equivalent to total weight over 1 plus the moisture content divided by the total volume. So, substituting, gamma dry is equivalent to 0.028282 kilonewtons divided by 1 plus moisture content 7%, make it in decimal form 0.07 divided by the total volume 0.0016 cubic meter. Computing, we will have a dry unit weight of 16.474 kilonewtons per cubic meter. And this is our second requirement, the dry unit weight of the excavated soil in the field. And then the last requirement, compute for the relative compaction. Again, relative compaction, the ratio of gamma dry determined in the field with respect to gamma dry maximum determined in the laboratory. Substituting gamma dry in the field, already compute the value, 16.474 kilonewtons per cubic meter over the maximum dry unit weight in the laboratory given in the problem. That is over 19 kilonewtons per cubic meter. Then we will have to multiply this by 100%. So computing for the value of relative compaction, we have 86.706%. And that will be our third requirement for our sand cone method test problem.